Hello all, myself Mangesh Gadi. Today I am going to explain the basic concept of PN junction diode. So before going to the PN junction diode, what is actually, or I am going to explain the concept of energy band diagram. And after energy band diagram, what is the working principle of PN junction diode is in the unbiased condition. So this is unbiased PN junction diode. So what are the different types of materials are present in electronics? So the three types of materials are present. So first type of material is the conductor, second type of material is the insulator, and third type of material is the semiconductor. So what is actually the conductor means, or the energy band diagram of conductor? So there is the two bands are present in the energy band diagram. So one band is the valence band and another band is the conduction band. And in the concept of conductor, there is no energy gap is present between valence band and conduction band. It is called as conductor. That means the conduction band and valence band are overlap with each other. So there is no energy gap is present in between valence band and conduction band. This type of material is called as conductor. So what is the definition of conductor? So any material that allows the electric current pass through it is called as conductor. So which type of materials are called as a conductor? These are some examples of conductor. Copper, aluminum, or any type of metal is called as conductor. Then the energy band diagram of insulator. Similarly, in the case of conductor, it is also having two bands. So first band is the valence band and another band is the conduction band. So the difference between previous, that means the conductor and insulator, is there is the gap present between valence band and conduction band is larger as compared to the conductor or also the semiconductor. So because of this gap present in between valence band and conduction band, so it is nearly about the 8 electron volt, and because of that, this gap, electrons present in the valence band are not easily moving into the conduction band. So this material acts as an insulator. So what is the definition of insulator? So insulator is any material does not allow electric current pass through it. So what are the different examples of insulator? So plastic is one of the insulating materials. So you are very familiar with the plastic, wood, rubber is also called as insulators or insulating materials. Next is the energy band diagram of semiconductor. So semiconductor, that means there is the properties in between conductor and insulator. So that's why this is called a semiconductor. So similarly, it is having valence band and conduction band. And the gap is in between valence band and conduction band as compared to the insulator. This gap is very small. It is nearly about 1 electron volt. So because of that, the electrons present in the valence band are easily moving into the conduction band when there is some external energy is applied to that valence band. So what is the definition of semiconductor? So semiconductor is any material or the property of that material is in between conductor and insulator. So what is the example of semiconducting materials? So silicon is one of the semiconductor material, and the germanium and etc. are the semiconducting materials. So what are the different types of semiconductors? So semiconductor are having two types. So first type is the intrinsic semiconductor and second type is the extrinsic semiconductor. So what is intrinsic semiconductor means? So intrinsic means pure. So that's why the pure form of semiconductor is called as intrinsic semiconductor. And it exhibits a poor conductivity. Why it exhibits a poor conductivity? So because of that, gap is present between the conduction band and valence band is very small. So because of this gap, the electrons present in the valence band are easily moving to the conduction band. There is no any external energy, or it relies on the temperature. That means when there is the room temperature also, the conductivity happens in the intrinsic semiconductor. So because of that, this semiconductor is having a poor conductivity. So the conduction relies on temperature. So because of that temperature, when there is the temperature is increases, conductivity happens in that semiconductor. So because of that, this semiconductor material is having a poor conductivity. then the number of electrons and holes are present in the intrinsic semiconductors are same, or the equal number of electrons and holes are present. Then what are the examples of intrinsic semiconductor? Silicon and germanium is one of the example of intrinsic semiconductor. Then what is actually extrinsic semiconductor means? So as compared to the intrinsic, extrinsic is the impure form. So impure form of semiconductor is called as extrinsic semiconductor. So it exhibits a better conductivity. So because of that, in the extrinsic semiconductor, conductivity not depends on the temperature. So it exhibits a better conductivity as compared to intrinsic semiconductor. Because there is the energy gap also, there is the one of the reason is having a better conductivity. The energy gap present is in between conduction band and valence band is higher than intrinsic. Then the conduction is depends on the concentration of doped impurity. So which type of impurity is added. So the conduction is depends on that impurity. And the majority of electrons and holes depends on the type of extrinsic semiconductor. So which type of impurity is added in that semiconductor. So the electrons and holes are depends on that type of impurity. So the example of extrinsic semiconductor is gallium arsenide, GaAs, or gallium phosphide, etc. So what are the different types of extrinsic semiconductor? So extrinsic semiconductor is having two types. So first type is the p-type semiconductor and second type is the n-type semiconductor. So what is p-type semiconductor means? So p-type semiconductor is having a trivalent impurity. That means in the p-type semiconductor or in the extrinsic semiconductor, when there is the element, one of the element is present in the material. So suppose this element is having 3 electrons in the outer orbit. So these elements are used to adding the impurities in that semiconducting material. So because of that, the p-type semiconductor material is formed. So the example of trivalent impurities are boron, gallium, indium, or aluminum. That means in the outer orbit of boron or gallium or indium or aluminum, the 3 electrons are present in the outer orbit. So because of that, this is the trivalent impurities elements. It's used to adding the impurities in the extrinsic semiconductor to form the p-type semiconductor. What is actually n-type semiconductor means? So n-type semiconductor means there is the pentavalent impurity. Similarly, in the p-type, these elements are having 5 electrons in the outer orbit. So this is called as pentavalent impurity. So what are the different examples of pentavalent impurity, or which elements are having 5 electrons in the outer orbit? So these are the phosphorus, arsenic, antimony, bismuth. So these are some examples of pentavalent impurities. So what is actually p-type and n-type semiconductor means, and what actually is used to form the p-n junction diode? So let's move towards the p-n junction diode concept. So because of that, p-type material and n-type material, which is combined with each other to form the p-n junction diode. So this is one material, it's called as p-type material. This is another material, it's called as n-type material. So it's in between, there is one junction is present. So the name of that junction is p-n junction. So the name of that diode is p-n junction because of that p-type n-type material, and there is the junction is in between p and n. So in the p-type material, actually holes are having a positive charge and electrons are having a negative charge. So in the p-type material, holes are having a majority charge carriers and electrons are having a minority charge carriers. So because of that, in the p-type material having a positive charge. Similarly, in the n-type material, electrons are majority charge carriers having a negative charge and holes are having a positive charge. So because of that, the holes are minority charge carriers in n-type material. And there is the 2 electrodes. One is the anode, which is connected to the p-type material, so which is called as anode, and another one is the cathode, which is connected to the n-type material. So this is actually the basic concept or basic construction of p-n junction diode. So how PN junction diode works in unbiased condition when there is no any voltage is applied. What happens in the PN junction diode? So this is open biased, that means there is no any unbiased, so there is no any voltage is applied to the anode and cathode. What actually happens in the PN junction diode? Similarly, there is having two materials, so one is the P type, another one is the N type, and there is the holes are having a majority charge carriers, electrons are having a majority charge carriers in N type, holes are having a majority charge carriers in P type, and here is the junction. Okay, so what happens when there is no any voltage is applied to the anode or cathode? So you know about holes are having a positive charge and electrons are having a negative charge. So because of that, positive attracts the negative, that means opposites are attract with each other. So because of that, positive holes are attracted these electrons, so these electrons are moved towards the p-type material like that. So because of the concentration of holes are higher than the electrons, so these electrons are cross the junction and gathered near to the junction. So these are the electrons are cross the junction and gathered near to the junction. Similarly, because of the electrons are having a negative charge, so these electrons are attracted to the positive, and these positive ions are gathered near to the junction like that. So because of that, negative ions and positive ions are present near to the junction, and this is the negative ions, this is the layer of negative ions, and this is the layer of positive ions, and because of that two layers, there is the one region is present near the junction, and this region is called as depletion region. And because of that depletion region is present in between the p-type material and n-type material, electrons or holes are not moving or not crossing the junction. So this depletion region acts as a barrier of that conduction, and because of that depletion region is present near to the junction, in unbiased condition of PN junction diode, it acts as an off switch, or the conductivity is not happens in the unbiased PN junction diode. So you like this video, so please like my video and subscribe my channel. Thank you.